what do you see? If h is 0, where 0 is, if h is 0, then x minus 0 is just x, right? And then square. So y equal x squared is just a parabola open up at the origin, right? Right here at the origin. If h is positive, what happened? It shifts to the right, right? So it shifts to the right. Is the height changing? No, right? It's the only width, the only thing that changing is x values. If h is negative, I'm sorry, if h is negative, it shifts to the left. Right. So let me ask you a question. Y equal x plus 3 squared. Do you think it's going to shift to the right or shift to the left? We have left, we have right. How many say for left? Left, left, right. Quite a few. I'll explain to you why. So that's my general function. Now, if I compute h equal 3, then this is equal to what? X minus 3 squared, right? X minus 3 squared, when h is positive, I have x minus 3 squared, is going to shift to the right. When I compute h equal negative 3, what does it become? X minus what? Negative 3, right? Because the minus is the default. It comes from the formula. It does not come from the h. Right? It's always there. The minus is always there. All you do is plug in the values. Right? So this becomes x plus 3 squared. And in this case, it's moved to the left. As opposed to the parent graph, which is the one I have in dash there, which is kind of counterintuitive. Like if you look at the formula at first glance, well, it's plus 3, it kind of moved to the right. But in fact, it's plus 3 because you input a negative 3, right? So it moves to the left. When you input positive, it follows the formula, even though it looks negative, but that negative does not, it's not carried from 3, it's carried from the formula, right? So for Hanazawa shifting, if you adding, you shift left. If you subtracting, you shift right. Okay, and the height does not change. So we have Hanazawa shifting. The graph is going to be, in general, is called y equal f of x plus h. So the number is being added to the variable. If it's x plus h, you shift to the left h unit, like we did the shift to the left 3 units in our example. If we have y equal f of x minus h, it shifts to the right h unit. And the y value does not change. The only thing changes is the x value. I have h of x equal x minus 4 squared. What should I do? Right or left? Right. I know it's counterintuitive, just you had to keep that in mind. Shift to the right 4 unit, right? 4 unit. Basically, just copy and paste. So all you do is just shift it to the right 4 unit. Try to make your parabola a little bit curvy, because if you do it sharp at the vertex, it's the absolute value graph. It's a different graph. Try to make it curvy. So it's right here, f of x. Let me follow the h of x equal x minus 4 squared. You have any questions? You can learn this in statistic too, right? Vertical shifting. Oh, by the way, let me talk a little bit more about horizontal shifting. It doesn't have to be quadratic to shift left or right. It can be applied for absolute values, right? So here's my parent graph, y equal absolute value of x. If I add 2 within the absolute values, then I move left. If I subtract, I move right. Same thing, right? So same thing with square root. Y equals square root of x, that's the parent graph. Right? By the way, it cannot be negative, right? That's why the domain is from 0 to infinity. If it negative, then it's gonna be imaginary, which you can't see here because it's real coordinates. If you add 4 under the radical, you go left. You minus 4 under the radical, you move right. So it's the same deal for other functions. For vertical shifting, this is my parent graph, or I would say the basic graph, or the master graph. When k is positive, it looks like it shifts up, right? When k is negative, it shifts down. I know the illusion of the graph is say it looks like it's getting skinnier or bigger. It's not. It's just because it's moving up and down. Therefore, you have that illusion. So it's for the vertical shifting, it's pretty straightforward, right? Adding, move up; subtracting, move down. Right? So here, y equals x squared. If I add 3, I move up 3 units. If I subtract 3, I move down 3 units compared to the parent graph. Same thing with the absolute values. Add 2, subtract 2. Same with the radical. Add 5, move up 5, subtract 3, move down 3. So pretty straightforward. It hasn't get hairy yet. It will when you combine all that shifting together. So for the vertical shifting, the function is f of x, and then add h outside the parentheses. So basically, you take the whole function and you add to a number. As suppose here, you add the number into the function. Right here, you take the whole function separately, and then you add another number or subtract another number. So f of x plus k is gonna make the graph move up k units. If it minus k, make the graph move down k units. Is the y value change when you move up and down? Is the y value change when you move up and down? Yes, right. You move up and down, of course your range is gonna change, right? The only thing that doesn't change is your x. Right? It just move up and down. It doesn't move left or right. So this right here, we all did this in. Let's do this one. X squared minus 4. So move down 4 units. Copy and paste. And your vertex now, make sure you put the new vertex. Vertex now be 0, -4. That's called the vertex. 0, -4. Let me put the vertex here as well. This will be 4, 0. Because originally it was 0, 0. So on the exam, make sure you put the vertex. So that's okay. Pretty simple. Reflection of the graph. Well, that's most of it. So square root of x. If I take y equal negative square root of x, by the way, y equal negative square root of x means what? Means what? Is a negative, is carried from the function or is it separate? Separate is -1 times the function, right? So the negative had nothing to do with the function. It comes from the constant. So when we have that, your graph gonna flip over the x-axis. Right? It's so the green one will be mirror image of the dash one. Gonna flip over the x-axis. If I have the negative inside the function, when the negative is carried by the function, then I'm going to flip over the y-axis. What can you tell me? Let me remove the red one. What can you tell me when you flip over the x-axis? The first type of reflection. What can you tell me? Is the domain change? No, right? Domain doesn't change. Still 0 to infinity. Is the range change? Yes, right. So it is opposite, right? Instead of a positive, it has -5 there, -5, 10 there, -10. So the range is opposite of the original range when you reflect over the x-axis. What about the red one? Domain change? How does it change? The opposite of the original, right? And then does the range change? No. So remember those. Well, you don't have to remember those. If you're in doubt, draw it out, right? See what happens. So for fraction term, if the negative one times the function, then it's going to reflect over the x-axis, and we call this the vertical reflection. The y value is the opposite sign, and the x values remain the same. If the negative is inside the graph, is belong to the function, then you reflect over the y-axis. This is known as the horizontal reflection. Horizontal, right? You kind of go flip to the left side or the right side. X value is the opposite of the original, and the y value remain the same. Here the example to show you how algebraically is opposite. So if you look in 9, y equals square root of 9 is 3, right? But y equals negative square root of 9 is 3. You see the y value is opposite. We graphed 3b in decimal. I'll copy it here. Oh, they already did it right there. I'll make it yellow or highlight. Okay. So far, so good. I know that when I say something here in class, you can understand like right away, most of you. But it's a different story when it comes to exam because there's a lot to remember at once, right? And they look similar. Like, God, what should I use? It's understandable. I experienced the same thing. Now, we have horizontal shifting, vertical shifting, reflection. Which order do I use first? There's an order. Otherwise, it might be a disaster when you just kind of feel like do whatever I want. Very good. No, 4A, I'm not going to say anything because it's there. You can read it. This is way they prove that if you don't follow the order, your graph is not wrong. Your new graph is not wrong. You read yourself. But I'm going to go to the actual problem. So here is the steps. I would say step 0. Identify the parent graph. Is it quadratic? Is it absolute value? Is it radical? Or a cubic? It doesn't matter. You be able to identify your basic graph, right? Your parent graph. And then step 1. Here's step 1. Step 2. Step 3. So we do horizontal first, and then reflections, and then vertical shift will be last. Vertical shift always last. Always last. Vertical shifting. Oh, do you have any question before I move on? Yeah, almost there. All right, let's take a look at this one. Let's graph this one. This y equal, let me write down here for you. I'll copy it down. Y equal negative absolute value of x minus 2. I'm sorry, x plus 2, close absolute value plus 3. Blue. So the first step, what do I do? First step, shift to the right, right? Horizontal, that's the first step, right? So yeah, step number one, I will say step one, right two, right two. Step number two, left two, sorry. See the what I meant? When I used to see plus two, I automatically think it's to the right. Thank you. Left. Left two. Step number two. Yeah, very good. Over what? X or Y axis? X or Y? What changed? If the negative being multiplied to the function, what changed? The range changed, right? So you flip over the x. I know it's kind of counterintuitive, but because the range changed, you flip over the x-axis. Step number two. The last one will be up 3, right? Vertical shift up 3. So let's do that. So move to the right 2. Right, I'm sorry, I keep saying that. Move to the left 2. Left 2. And then you flip, so it looked like that. I'm not gonna draw it. I'm not gonna draw it. It looked like that. And then you pull the vertex up 3 units. 1, 2, 3, right there. That's your new graph. You need blue. Same width and everything, it's just different position. So your new vertex will be -2, 3. Do you have any questions? That's a good step to ask. Because you probably similar to this. Okay, all right. Square. All you do is pick the right graph. Right, move on to number 5. A little bit more abstract for number 5. Sorry, you need it. If it more skillful, you can take a picture. Sometimes you copy it down, you forgot a square, you forgot a negative in front of the function, stuff like that. For number 5, it's a little bit more abstract. They don't give you the actual number, they give you a letter, and then they ask you to shift. For example, I have, here is all the points of the original graph, the parent graph, y equal f of x. See, that's what I meant by abstract, right? They don't give you what kind of function it is, just a bunch of points. Now, if I want to graph y equal negative f of negative x, then what do? So say you don't know any of these. Say, just pretend you don't know these. How would you come up with y equal, say you don't know that whole, how would you come up with y equal f of negative x? Yeah, you just, instead of positive x, you have negative x, right? Just multiply x with -1. So -1 times -4 is +4, right? -1 times -1 is +1. -1 times 1 is -1. -1 times 4 is -4. Is the y change? Is the y value change? No. So they stay the same. What about this one? Say you don't know anything about this. Yeah, you take -1 times the x value and then add 2 to the y value, right? Because here the 2 being add to the whole function. So same thing for x over here. Or the y, you look at the original, everything shift up 2 units, right? 2, 4, 1, 5. Okay, yeah, so far so good. So you understand that where the table come from. Let's do this one. Y equal negative f of x plus 1. If you confuse, where do I add the 1? Do I add to the x or do I add to the y? How do I know? Is it being added to the x or being added to the y? To the x, right? Inside the parentheses, so that's horizontal shift, right? Add to the x. So everything from the original, you add 1. So let's do this. -4 plus 1 is, I'll do this with you. Let me see how I use the color in my notes. Let me highlight that. So the black one is add 1, and then the yellow part is when I add the negative in front of it. So A is -4 plus 1, parenthesis yet, sorry, comma what? 0, -0, right? The negative y. -1 times y, -1 times 0 is still gonna be 0. So A will be -4 plus 1 is -3, comma 0. B, -1 in the original for x, and then I have to add to 1. And then for the y, I have 2, but then I gotta put a negative in front of y, right? -1 times 2. So B is gonna be 0, comma -2. So far, so good. I'll let you guys do the last 2. You tell me what you got. Don't know what to do. Write out the original first. C gonna be 1, comma -1. What do I do with the 1 here? Add 1, right? This is just a pattern. Just add 1 everywhere for x. And then make sure you add the negative 1 times y. Usually I just put negative, I don't have to say negative 1. So my C point, if you simplify that, will be C2 comma positive 1, right? Can someone tell me what your D is? What's your final D? Thank you. 5 and comma. Thank you. Is there any question? Right, now we've got it. We've got it. So A is negative 3, 0. B is 0, negative 2. Oops, sorry, wrong one. 0, negative 2 right here. C is 2, 1. D is 5, negative 3. 1, 2, 3, 4, 5. Let me connect the dot. Of course, you have ruler will be better. Which one with letter?
All of them. Does it put +1 meaning the whole thing goes flat?
No. This formula. Here. Let me. Don't change. Don't write anything. Originally, I have y equal x minus h squared, right? Here I have y equal x plus 1 square. It's a different thing. This is the default. This is the second one is the default for this problem only. But yes, yeah. Overall, when you, I just like out of blue, I'll give you something like y equal x minus 2 square. You move to the right. But this one I have to follow the new default problem. Yes.
So you're giving us y equals x. Y equals negative x minus 2 squared, and I'm flipping it over now.
Yes. Yes. Vertical stretch and vertical compression. So far we did vertical shifting, horizontal shifting, reflecting over the x or y axis. Now the vertical stretch or vertical compression, meaning either your graph gonna get skinnier. When it's skinny, meaning it grows faster, or it get wider, meaning it grows slower, right? So let's take a look at Cosmos. Oh, this is the one that we just did. Let's take a look at y equal. Uh-oh, I thought I saved it. Hang on. Let me fix this. Here's a linear graph, y equal x. Look what happened when I change the value of the slope. When I change value of a. When a is 1, this it's just y equal x, right? 1 times x is x, right? So when a is 1, it's just is the red graph and matching with the dashed graph, right? When the slope is negative, what happened? Let's do positive. When slope is big, 6, 7, 8, 9, 10. What happened to the red graph compared to the dashed one? It's steeper, right? It gets steeper. So that means the function grows faster, right? Function grows. Say if you want to evaluate one, well, 1 for the black one is 1, right? But 1 for the red one is all the way up there, right? So it grows faster. But when the positive is small, is between 0 and 1, then the function get less steep. Same thing here with the square function. That's y equal x squared. See what happened to b when the coefficient of x squared is get larger, it's steep, it gets skinnier. When the coefficient is between 0 and 1, not negative. I'm not talking about negative. 0 and 1, because negative we flip right over the x-axis. 0 and 1, it gets wider, right? It gets wider, yeah. Right there, if it near 0.1, it get very wide. Right? That means the function grows slower. The function f of x vertical stretching, then we're gonna have a vertical stretch. Maybe I'll say vertical stretch. I'll say get steeper for the linear, or usually I just say get narrower. Linear, or I want to say it. If f of x, it's the same thing, but if the coefficient of the function is between 0 and 1, I'm not talking about negative. If it's negative, then it will flip, right? We're not gonna talk about that. Between 0 and 1, then the graph get wider. We call vertical compression. You know what? When I studied it, I never remember those terms. I just use my layman term, wider, narrow, skinnier, fatter, however it worked for me, so I can remember it better. You do the same, right? But maybe it's helpful if you know the term. But if they ask you on the exam, like vertical compression, then what does that mean, vertical compression? You can ask me, okay? If you don't know what I mean on the exam, ask me. Yes, right, between like 0.1, 0.2. Yeah. For the vertical stretch or compression, is the y value changed? No, right, you get bigger or narrow. You get narrow or wider. It's the thing you change is the might be the domain. Might, I say might. Domain for the red one and the dash one, what did you think the domain for those? Everything, right? Right. Eventually, it's always all real number, right? Just matter how fast it goes to infinity. I don't have an example here for you. I don't. I'm sorry, I don't. I thought I did. So I come back. This one. So here, if I multiply the function by a third, that will be the blue one. That'll be your blue graph. That'll be this one. If I multiply the function by 3, that'll be the red one. The black one is the parent portion. So it got narrow. Now, how much do I stretch or how much do I shrink? If you multiply by 3, you're gonna stretch by 3 times as the original, right? Let me see. Yeah, right there. If it's 2, 4 become 2, 12. 4 times 3 is 12. The y value multiplied by 80 and the x value remains the same. But my range does not change. Okay. My range does not change overall. It does not change. It's still from 0 to infinity. They're talking about the y value, how fast it go, right? So they say for vertical stretch or compression, the y value multiplied by a, right? So it's faster by a units, right? It grows faster by a units. But overall, the whole picture range does not change. But within inside each point, this will grow 3 times faster compared to the black one. This will grow 3 times slower compared to the black one. Right, let's do number 7. G of x is all these points. And for big F of x, I'm going to double my function. So what do? If I double it, is the x change? No, right? That's what they say. I want the one I highlight in yellow. X remain the same, and you double the y. What color do I do here in my notes? I use green, but I'm going to use red. I'm going to use red. So 0, comma 2 times 0 is 0. Thank you. For B, x stay the same. 2 times 2 is 4. I just double the y value. So C will be 4, comma 4. D will be 5, comma 8. And E will be 7, comma 0. Oh, it's a shame they don't graph the black one for you. I thought they give you the, well, we'll do ourselves. 0, 0 here. I'm doing the G of x. 2, 2 right here. 4, 2, 4, 2 right here. 5, 4. Right here. And 7, 0. That's just the x and a step. 5, 6, 7. 2, 4, 6, 7. Let's grab the red one. 0, 0. Still the same as the black one. 2, 4. 2, 4. 4, 2. 4, 2. Oh, it's 4, 4. Sorry. 4, 4. 5, 8. 4, 6, 8. And then 7, 0. What happened? What happened to the red one compared to the black one? Vertical stretch, right? Get higher, right? Why don't you guys try the vertical compression? I'll walk around, see how you do. Good steady hand. Good. I had a colleague, he draw a most perfect circle there is. I love his circle. It's really, really round.
Every time I try to call it, I just haven't did that one.
X plus one, not seven. Is it one or seven?
That's a lot.
Oh, okay.
Sorry, John.
No, that's all right. I just don't want you to go home and you forgot what you wrote. Left one, yes.
So the square root would only matter.
No, no,
if it
no,
was
no,
a
no,
plus.
no. Don't worry about the square and all. Here
Okay.
we worry about the shifting. Right?
Okay.
Yeah, don't worry about the function.
Alright, sure.
You
That's
got it right. Yeah. Yeah, you try one. You're gonna. You just pick the right graph, but you gotta know which step to shift first. Let me see. You try two. You only have two. You try to do. Yeah, very good, very good, very good. Let me see your compression. Yeah, it's just everything. What instead of sorry, let me move back. Everything just everything is reduced by half, right? For the y values. Yeah, very good, very good. Good, yes. You okay? Okay, you don't want to write down. Let's see. Yeah, I can take a look at your graph. Good, good, good. All right, that's okay. Very good. Yes. What's your notes? Very good. Now, I don't feel like doing it because you all do it for me already. So let's show you how I did it in my. Who doesn't like me to do like g of x or big F of x? So I kind of replace. So x here. For y1, that's your parent graph. That's g of x. So right there, that one. Y2, that's my big F of x. That's vertical stretch. And then the vertical compression, that's that one. So it looks like everybody has the same thing I do. Is we have horizontal stretch. I'm sorry, horizontal shifting, reflection over the x-axis or y-axis. When do reflecting over the x-axis? Just recapping. Yeah, negative multiply to the whole function, right? So you reflect over the x-axis or reflect with the y-axis and the negative include in the variable. And then the vertical shift, which is always last. We have vertical stretching, you get narrower or steeper. Vertical compression, you get wider. Right. Now let's put them all together. Which one comes first? Here is a step. Here's a step. So again, they don't write it here, but I like to include step 0 is the parent graph. Make sure you be able to identify your parent graph or basic graph. Right? Is that the quadratic family? Is it radical family? Cubic family or all that. And then here's step number 1, always horizontal shift first. And the last step, always the vertical shift. And then between reflection, that's step number 2. And step number 3, that will be the stretch. For the stretch, if you multiply a function by a positive number, your function get narrower, right? If you multiply a function between 0 and 1, like a fraction between 0 and 1, then your function gets wider. We're gonna grab this one. But before I grab that one, let's clean that up a little bit. Before you grab anything, the coefficient of x has to be 1. Here I see 2, so I gotta clean it up a little bit. I'll just manipulate it around. Here is the recall. Here's a reminder. Recall stuff. You learned this before. I need the coefficient of x to be 1. I need, so that means I have to factor out the 2, right? So what I do is here I factor out the 2 within the absolute value. You're gonna rewrite the absolute value every single time. And then if you have absolute value of a times b, it's the same thing as absolute value of a times absolute value of b. So it's the same thing as absolute value of 2 times absolute value of the second factor, which is x minus 2. What I don't want to see you do is you do this. It's wrong, right? Because how many factors do you have here? How many factors? 2, only 2, right? Factor means multiplication. I have something multiplies something. This plus and minus is not counts as factor. That's terms. Absolute value of 2 is 2. Absolute value of x minus 2, I don't know, because I don't know x, right? So just read it as is. Same thing with the radical. I need to make the x have a coefficient of 1. What I do is I factor out the 16. So 16 times x is 16x. But now I run into a little problem with the negative 5. Here I had to multiply. I had to change the new 5 become what? 5 over 16, right? Because when you distribute the 16 from outside, it get back to you 5, right? Make sense? Okay. Let's just recall. So this one right here, they kind of do it for us. They factor out the 2. Factor out the 2. So everything they stay the same. Do not change. Do not get rid of this. You need that. So we did that before. So absolute value of 2 times x minus 2. It means it becomes 2 separate absolute values. Absolute value of 2 is 2. And then don't forget to bring over the negative. Then this is stay this inside the absolute value. And then x3. Right, you tell me what should I grow? How should I? The step. How do I how do I shift that? What first? Step number 1. Step 0. What's the parent graph? Absolute value of x, right? Step 1 is write 2, right? So write 2. That's step number 1. Step number 2. Reflect over flip over the x-axis. Make it a little bit. Yeah. Flip over the x-axis. Step number 3. Your graph getting skinnier, wider or narrower? Narrow, right? Narrow means it go faster. Here you multiply by. We already take care of the flip thing, so forget about that. Here is the positive 2, right? So you're gonna vertical stretch, right? So that's step number 3. By how many units in the y direction? 2, right? So step number 3. Vertical stretch. And last one, always the last one, vertical. Of 3. Step number 4. do this by hand first, and I'll show you how the rest one looks. Move to the right too. So here's my parent graph. I move to the right too. Let me see what color do I want to do color so you can see each step. It didn't say. That's okay. That's all right. That's all right. That's all right. Right too. So it's kind of look like that, right? Okay, I'm not gonna draw the whole thing because I'm gonna move again. And then you reflect over the y-axis, so become like that. Remove that thing. And then what else? It stretch. So this, remember, this is your it has the same width as the original. You stretch 2 is mean you multiply the y coordinate by 2. At this point, I guess I have to draw it out. I'm gonna try by 2. By the way, when I flip, what changed? The y, right? Everything is changed. So if I have positive y up there, I'm gonna have a negative y here. So so let's see if I have yeah, if it was up to me, I just kind of estimate. I'll just estimate. You know, it's not a big deal. So like that, right? If it's stretched, then it gets skinnier. So gonna be like that compared to the parent, right? And then what do? The last step, you move up 3. So you pull the little pointy point up 3 units. There you go, your final graph. See, it's skinnier than the parent graph. Right? Just grow faster. But let me show on decimals. I want to graph this one. First, I'm gonna begin to write, if it is exam, then you're gonna ask to write the function. So the coefficient is 1. Right? We already did that. Step 1 or step 0, parent function. Parent function is the y equals to absolute value of x. Step 2 is a vertical shift 2 units. And step 3, reflect over the x-axis. And then step 4, you stretch, right, so it gets skinnier. And then step 5, vertical shift, move up 3, there you go. Let's do this one, last one, and then we're done. This one. What should I do first? Huh? Factor, right? So what do I do? What do I do? Y equal, let's say y equal 1/2, factor out the 1/2, whatever number in front of the x, you factor out, and here's x. 1/2 times x is 1/2 x. What about the -1? What should I minus? What's next? What number should I put next to get back to -1? Flip the other way around. 2, right? 2, right? So 1/2 times 2 is -2 is -1. Then minus 3. And then now you break it apart. Absolute value of 1/2 times absolute value of x minus 3 minus, minus 2. Inside absolute value, and then minus 3 outside. Absolute value 1/2 is 1/2. Now you don't need the absolute value anymore. However, I don't know what the x minus 2 is. It could be positive if x is bigger than 2. If it's negative, is it less than 2, right? So we leave it in the absolute value. My parent function is y equals absolute value of x. Right. That's the parent function. Sorry, it's kind of difficult for me to write when I'm standing. All right, you tell me, step. Mhm. Keep going. Stretch or compress? Compress, right? It means get wider. Wider. It's because between 0 and 1. So compress. Or if you forgot, just say wider by 2 units. Right? I'll still give you full point on the exam because I know what you mean. And then last will be up 3, down 3. We don't have that reflection because there's no negative here. All right, now they want the exact graph, which is make it difficult. If it's like that, I kind of eyeball it, copy and paste. But here they want the exact, more precise. So here my parent function, they put a little 2 point there. Move to the right 2. Oh, good God, I always move to the right 2. Hang on, move to the right 2. So everything shift by 2. So this point here become this one right here. Yellow, right there. Everything move by 2. You're gonna move that point by 2. So by 2 as well. And then the center will be right at 2 on the x-axis. I meant by is a pain in the butt. So that's so good. It's helpful if you have a point, you can trace it. Now, what do? Compress by 2. What does that mean? It gets skinnier by 2, right? You get skinnier by 2. I'm sorry, it get wider. It get wider by 2. It get wider by 2 on the y direction. So here, let me see. Here is 5, comma 3. Here is -1, comma 3. You have to double the y value, right? So it's gonna be what? 5, comma 6, -1, comma 6. 5, comma 6. So here, -1, comma 6. You understand this part? No, let me remember my notes. No, I don't multiply by. I multiply by 1/2. Yeah, 1/2. Sorry. I did the stretching. Sorry. So it's gonna be what? 3/2, right? 3/2. Yeah. So 1.5. So 5, 1.55. 1.5 is right here. I'm sorry. Don't shoot the messenger. I'm just trying to show you how to do this. Yeah, let's get wider. Right there. I'll let you go soon. Whew. And then we move up to what? I'm sorry, we move down to what? 3 units, right? 3 units. So let's say 1/2 and another 1/2. That's 3. So right here. Right here. One, 2, 3. Right there. Don't worry, I'll post this. I want you to listen to me. I'll post this. To see it. But do you understand what I'm doing? Tracing the points. Yes.
There's 3 points. Write down those points.
Yes. Yes. Whichever way it works for your mind, right? Let me show you one thing and then I'll let you go. Real quick. So the 2 point I'm tracking is right there. So the first one moves to the right? And then the yellow one, I make it wider, compression. And then the last one, there. Yay. Yes, you can leave if you don't have any questions. Yes. Oh, you try too. I'm sorry. Thank you for reminding me. Thank you for reminding me. Describe the transformation. It's lagging. Have a wonderful weekend. I'll see you next Monday. Bye, Zuri.